Hello students, how are you all doing? Are you ready to master our previous topic? Okay, let's get started. Our today's topic is quadratic equation. So you must have known about polynomial equation in the previous class, right? So can you just tell me what the degree of a polynomial equation is? Yes, it is the highest degree of a monomial present in that polynomial equation. So if the polynomial equation is 2x to the power 4 plus 3x minus 5 equals to 0. Okay, so the degree will be 4 over here. Right. Now let's move on to the linear equation. What is linear equation? Linear equation is a type of polynomial equation where the degree will be 1 and the general form can be expressed as ax plus b equals to 0, where a must not be equal to 0, because if a becomes 0 then it will be b equals to 0, the uniform polynomial equation. Right. So that polynomial equation has the degree 0, so it is not going to be a linear equation. So a must not be equal to 0. Now let's move on to the quadratic equation. Okay. So what is quadratic equation? Quadratic equation is a type of polynomial equation where the degree of the polynomial equation will be 2. Okay. And the general form can be expressed as ax squared plus bx plus c equals to 0. Okay. And a must not be equal to 0. So can you guys tell me what will be happen if a becomes 0 over here? Yes, I know it can be. You guys are very smart. Just think out. Okay, I am going to explain. If a becomes 0, then the equation will be reduced to bx plus c equal to 0, right? So what is the degree of that uniform equation? Yes, the uniform polynomial equation has the degree of 1, and what do we call it? Linear equation. So it is not going to be a quadratic equation anymore, right? Yes. So we must have to remember that a must not be equal to 0. It's very important. Okay. Now let's move on to the roots of the equation. What is the roots? What are the roots of the equation? Yes, it is the value of a variable which can satisfy the given equation. And solving an equation means we have to find out the roots of the equation. Okay. Now before proceeding further, I want to give you a brief example. So can you guys tell me about two consecutive natural numbers whose product is 30? If your answer is 5 and 6, congratulations to you. Yes, you have already found the solution of a quadratic equation. Can you believe it how? Okay, I am going to show you. Now let's take x as the smaller number and x plus 1 is going to be the larger number because these are consecutive natural numbers. So their product is x into x plus 1 equals to 30, right? So multiplying by x, we get that x square plus x equals to 30, and take that 30 to the other side. It is x square plus x minus 30 equals to 0. It's not that a quadratic equation. Yes. So you must have known how important it is to solve a quadratic equation, right? So there are basically 3 ways to solve a quadratic equation. So number 1 is factorization. So at the very first, we have to write the given equation in the standard form of ax squared plus bx plus c equals to 0. Okay. So here, in this case, we have to factorize the quadratic polynomial. Okay. And after factorizing, you will get the factor. Okay. So we can see that for each of the factors becoming 0, the product is going to be 0 also. Right. So we can say that for x minus 5 equals to 0 and x plus 6 equals to 0, the product is going to be 0. So corresponding values are x equals to 5 and x equals to 6 minus 6. So these two values are actually satisfying the given equation. These two values are the roots of that quadratic equation. Okay, it's not that interesting. Yes. Now let's move on to the next method, which is completing the square method. Now let me tell you, most of the students find this method very difficult, but trust me, you will find it very easy if you follow the procedure step by step. Correct? Yes. At the very first, you have to write the given equation in the standard form, ax squared plus bx plus c equals to 0, and you have to divide the both sides of the equation by the coefficient of x squared. That means a in the general form. Okay. So it will be in the form of x square plus x minus 30 equals to 0. If you take that equation as an example. Okay. Now let's focus on the variable part. We have to complete the square from this variable part of the equation. So forget about everything. Let's focus on the variable part only. Okay. So to complete the square, we will use two formulas, which is a plus b whole square equals to a square plus 2ab plus b square, and the another one is a minus b whole square equals to a square minus 2ab plus b square. Okay. So let's compare this formula's expansion term by term. So here a square is corresponding to x square over here. So we have to make this x corresponding to 2ab. So we will basically multiply and divide by the same number 2. Okay. So it will be in the form of 2ab. That means 2 into x into half, which is actually x, right? So it is not going to be confusion, right? It is actually the value of x. It is not going to affect anymore. Okay. So it is 2 into x into half. So we have got the two terms of that expansion. So only missing terms are b square. So we have to add that term. So what is b? So b is here 2ab. So b is corresponding to half over here, right? So we have to add and subtract that b square, that means half square from it. Okay. So we have added and then subtracted. Okay. So it is not going to be any error in this. Okay. It is all equal as previous expansion. Okay. Now here x square plus 2x into half plus half square is actually corresponding to the same of that a plus b whole square formula, which is x square plus 2ab plus b square. So actually this expansion is x plus half whole square, right? So we will write that in that term. Now after that we will write the rest of the part, which is minus half whole square minus 30 as a separate square. Okay, separate partial square. So here it is 121 by 4. So we will write in the square format. So it is becoming 11 by 2 whole square. Now next formula we will be using is a square minus b square equals to a plus b into a minus b. Okay. So comparing term by term, we can get that a square is corresponding to x plus half whole square and b square is corresponding to 11 by 2 whole square. Okay. So applying that formula, we can factorize that algebraic expression, polynomial equation, that we can get that x plus half plus 11 by 2 into x plus half minus 11 by 2 equals to 0. So simplifying it, we can get that x plus 6 into x minus 5 equals to 0. Okay. So the roots of the equation will be x equal to minus 6 and x equal to 5. Right? It's very interesting. Right. So the next method is applying the quadratic formula. Okay. So it is basically we have to do compare the given equation with the general form of the quadratic equation, which is ax square plus bx plus c equal to 0. Okay. So let us take this example as here a is corresponding to 1 over here, right? Because the coefficient of x square is 1 here, and b is corresponding to 1 also, the coefficient of x, and c is the constant term, it is corresponding to minus 30 over here. And we have to put this into the formula x equal to minus b plus minus square root of b square minus 4ac by 2a. Okay. So if we substitute all the values of a, b and c, we can get the roots. Okay. So for x equal to minus b plus square root of b square minus 4ac by 2a, and x equal to minus b minus square root of b square minus 4ac by 2a, we will be getting at most two different real roots. Okay. Yes. So there may be circumstances where b square minus 4ac can be negative. Okay, that means less than 0. So in that case, we will not get any real roots from this. Okay, and if b square minus 4ac is equal to 0, then we will be getting two equal real roots. Okay, and if b square minus 4ac is greater than 0, then we will get two different real roots, and that b square minus 4ac is called the discriminant. Okay, so in this session you have learned how to solve a quadratic equation. In the next session, I will get back to this. Till then, goodbye and take care. Okay.